Hey everyone, my name's Trevor, and in this video I'm going to show you how to create a typing text effect in Unity. The text will type out one letter at a time as seen here. While the text is typing, we'll hide things like this continue icon to give the effect a more polished feel. We'll also be able to press a button while the text is typing that will bring us straight to the end of that line of dialogue. And last, I'll also show how to handle displaying rich text tags with this effect, which can be used to color, bold, or add other styling to parts of the dialogue. And of course, the code for this will be available on GitHub, which I'll link to in the description of this video. The Unity project we're starting with was created in a couple of previous tutorials, however that's not important regarding this tutorial, so don't worry if you haven't seen those. With that said, I'll put a link to those tutorials in the description of this video for anyone that wants to see how this dialogue system was created. Right now, the text only prints out one line of dialogue at a time without any typing effect. Regardless of how your dialogue system is implemented, somewhere in your code you probably have a line that looks something like this. In my case, this is in a script called the Dialog Manager. Dialog text is a TextMesh Pro U GUI object that references the dialog text UI in our scene, and currentStory.continue is simply the way that we're getting the next line of dialogue to be displayed. So in short, this line is just setting the UI text to a string. Instead of showing this string all at once, what we're going to do is create a coroutine that displays the line of dialogue one letter at a time, and then we'll replace this line with calling that coroutine instead. So let's do exactly that. We'll create a private method that returns an IEnumerator object called displayLine and have it take in a string called line. First, we'll need to clear the dialog text that's being displayed so that the previous line is no longer showing. We can do this by setting the dialog text.text to be an empty string. Next, we're going to create a for each loop that loops through each character in our line. We can use this method to turn our string into a character array, and then the for each loop will go through each character in that array. Inside of this loop, we'll add a letter onto our dialog text, and then we'll wait a fraction of a second before continuing on to the next letter. We can do this with the line yield return new wait for seconds, and then pass in typing speed, which is a variable that we need to create. At the top of this script, we'll create a serialized field private float typing speed variable, and then we'll initialize it to 0.04. The smaller this value is, the faster the dialogue will type out. And of course, we can now replace this line where we were previously setting the dialog text with calling our coroutine instead. We can do this using the method startCoroutine and then passing in a call to our displayLine method, where, as I mentioned, currentStory.continue simply returns the string line that we want to display. Remember to save your changes, and then we can jump into play mode to test this out. The text is typing out how we'd expect, but if you try to continue the dialogue before the line finishes, you'll see that there's an issue where the text just starts going crazy. This is because right now, when we continue, the coroutine from the previous line is still running, so we are actually seeing two instances of our coroutine method trying to display two different dialogue lines at the same time. We can fix this pretty easily by stopping the previous coroutine, if it exists, right before we start a new one. This will ensure that every time we start a coroutine to display a dialogue line, that coroutine will be the only one running. Back in the script, we can add a private coroutine variable called displayLineCoroutine. Then, right before we start the coroutine, we'll do a check to see if the displayLine coroutine has been set, and if it has been, then we'll stop it. We need to do this null check here because if we try to stop a coroutine that's null, we'll get an error. Then, when we start the coroutine, we can set the displayLineCoroutine variable like so. Now, if we go back into play mode, we'll no longer run into that issue. But perhaps we don't even want to allow the player to continue until the typing effect has finished, which is pretty standard for most games. First, we need to keep track of if the player can continue. We'll create a private Boolean variable called canContinueToNextLine and start it out as false. Then, wherever we're registering a button press to continue to the next line of dialogue, we'll want to add a condition to only continue when that Boolean is true. In my case, this happens in two places. Once in the update method and another time in the make choice method, which is getting called as an on-click function when the player selects a choice. Finally, in our coroutine, we'll set the boolean to be false when we first start displaying the line, and true at the bottom after the entire line has been displayed. So that will prevent the player from continuing until the text has completed. However, to add a bit of polish, it would be nice to hide certain parts of the dialog panel while text is typing and then show those parts once it's finished to give the player a visual indicator that they can continue. In this case, we're going to hide the continue icon as well as the choice buttons while the text is typing and then show them afterwards. Back in the script, I'm going to add a serialize field private GameObject continue icon variable, so we have a reference to the continue icon, and we actually already have a reference to the choices, which is an array of GameObjects as can be seen here. Now if I scroll back to our display line coroutine, at the top of the coroutine method we'll add a line to set the continue icon to be inactive, which will hide it. And at the bottom of the coroutine method we'll add another line to set the continue icon to be active, which will show it. For hiding and showing the choices, in this case we already have a display choices method that was previously being called after we were setting the dialog text. The only thing you need to know about this method is that it sets the choice buttons to be active or inactive depending on the amount of choices we have, if any. Instead of calling it here, we can move it to the bottom of our coroutine method to display them after the line has finished typing out. And of course, when the coroutine starts, we'll want to hide any choices that may be showing. We'll do this in a method called hide choices, which we'll create right now. Since we're storing the choices in an array of GameObjects, we can simply loop through them and then set them all to be inactive. Back in Unity, remember to drag in the continue icon to our script along with anything else you might have added to hide while the text is typing. As seen here, in my case, the choice buttons have already been dragged in. Then back in play mode, we'll now see that as the text types out, the continue button and any choices are hidden, and then as expected, they show once the line has finished. Sometimes though, the player might be impatient or might just be reading faster than the text is typing. It would be nice if when they hit the continue button while the text is typing, it displayed the entire line immediately. In our display line coroutine method, inside of the for each loop where we're displaying each letter one at a time, we can add an if statement to check if the player has pressed the submit button. This line will likely look different for you depending on how your input system is set up. I'm using Unity's new input system alongside a custom script called the input manager, but I'm not going to dig into that in this video. If you're using Unity's default input system and not sure what to put here, the line input.getKeyDown keycode.space should work. Anyways, if the player presses that button, we'll set the text equal to the entire line of dialogue and then use the break statement, which will immediately break us out of the for each loop. And now if we go back into play mode, we'll see that if we press the submit button while the text is typing, the entire line displays immediately and we're able to continue to the next one. The last thing I'm going to show is how to handle rich text tags. If you don't know what I'm talking about, rich text tags are a way you can add basic styling to your text. You can use them to change the color of your text, make the text bold, and so on. As long as you're using TextMesh Pro, you'll be able to use rich text tags regardless of how your dialog system is implemented. The dialog in this input system runs based on something called Ink, where the dialog itself is written in Ink files. Here's the Ink file for the dialog that's been playing. I'm just going to add rich text tags to change the color of the word happy to yellow, as well as the color of the word sad to blue. Because I'm using Ink to write the dialogue, which has its own use for this hashtag symbol, I need to include a backslash here as well to cancel that out. But just to be clear, you don't need this backslash unless you're using Ink or another system that uses the hashtag symbol for something else. I'm also going to change the color of the word not to be red, and to prove that our code will work with multiple tags, I'll add a second tag here to make the word bolded as well. As you might have already guessed, because of how the typing effect works, if we were to try playing this right now, it would show the rich text tags as they type out, which doesn't look very good. In our display line coroutine, we can add some code to check for when a rich text tag appears, and then display it all the way up to the closing character of that tag so that it doesn't show at all as the text types out. First, let's add a boolean called isAddingRichTextTag tag right before we enter the for each loop and initialize it to false. Then we'll add an if statement that will be true if the current letter is the opening tag character letter, or if we're currently adding a rich text tag. And if that statement evaluates to false, then we're not adding a rich text tag and we can display the dialog normally. So we'll move these two lines into the else statement. If we are dealing with rich text tags, we'll make sure is adding rich text tag is set to true, and we'll also add on a letter, but unlike before, we won't wait at all between this letter and the next. Then we'll need to check for the ending of the tag by checking for if the current letter is the closing tag character. If it is, we can simply set the is adding rich text tag variable to false to indicate that the entire tag has been added. And now if we go back into play mode, we'll see that things are working as expected. The word happy is colored yellow, the word not is colored red and bolded, and the word sad is colored blue. And that's it. Thank you so much for watching. If you enjoyed the video, please give it a thumbs up so more people see it, and if you want to see more from me, be sure to hit the subscribe button. Also, I just recently started up a Discord server. Feel free to swing by if you have questions about game development, want to recommend a topic that I should cover, or even if you just want to talk about whatever game you're building. You can also find me on Twitter and Instagram, where I mostly post updates for the game that I'm currently working on. But most of all, have an excellent day, and I hope this was helpful.